integration, different frameworks. So the other aspect as well is lean processes. Again, DevOps is about shift left and ability to respond to production issues before our customer realize that there is a problem. Plus, ability to make sense of those hundreds, if not thousands, signals coming from production systems quickly. And measurement, how our systems are performing, a basis and foundation for a continuous improvement. And the recovery, well, just let's think about sometime in the future, potentially we can build a system that are self-healing. So I'm looking forward to today's presentation from Datadog because they are just covering a lot of those items and topics that I just mentioned. So I'm going to hand over to Alison to introduce our speakers and as well as provide some housekeeping information. Alison, over to you.
Hey, thanks, Andre. Hi, everyone. For those who might be new to the meetup, my name is Alison Bennett, and as Andre said, I'm co-hosting the meetup with him. And tonight we welcome Brian and Ryan from Datadog. And we're going to hear from Ryan a little bit later on with his presentation and a demo as well. And Ryan will take your questions. I'll mention a little bit about Ryan and then I'll hand over to Brian to begin with. So just as an introduction to Ryan, he is a tech evangelist with Datadog and he's got 20 years of industry experience, which he brings to that role. He was recently a senior operations engineer at Samsung, and he worked on products such as Samsung Pay and SmartThings. And his bio says in his spare time, he enjoys building mechanical keyboards, taking pictures, and pretending to hike while taking pictures. So welcome, Ryan, and we're really looking forward to hearing from you a little later on. First up, I'd like to introduce Brian Clendenin. Brian's the enterprise sales leader for Western Canada at Datadog, and Brian's going to tell us a little bit about the company and also tell us how we can win a Datadog t-shirt this evening. So welcome, Brian, and I'll hand over to you.
Thank you, Alison. Yes, those I'll share what they look like. The Datadog t-shirts are actually quite soft and nice. So I think it'll be the questions that I'll ask. It'll be come down to who types the fastest. So we'll see. They're going to be very simple for this this giveaway. So thank you, everyone. As Alison mentioned, my name is Brian Clendenin, and I help run our Western Canada clients. So we've got quite a number of them across virtually every industry, from TELUS Health to Suncor, among many others. And so what we thought we would do today, and we're delighted that Andre and Alison invited us to be part of this event tonight, is really to talk about observability. As we have seen during the pandemic, a lot of the shifts of the way people work really has been a big tailwind for Datadog over the past 18 months with the move to the cloud and multi-cloud and hybrid environments. And it really came clear that there was a large need for observability. And so when we get to Ryan's portion, he's really going to dig in deep so that you can take away some best practices around DevOps and how you can help think about what you might be able to do within your own organization environments. So when we look at traditional monitoring across the board, there are several things that you want to take into consideration. So modern software applications are incredibly complex. So they have multi-tiered architectures with dozens of technologies spread over hundreds of thousands, if not compute units. So on top of that, the development teams are doing updates more frequently than ever before to get in front of the customers. And the challenge becomes often that they're without a single source of truth to understand where problems are arising and being able to streamline that incident resolution processes. So when we think about traditional monitoring tools that have typically been in siloed environments, the infrastructure metrics, they tell you when something is wrong, but they lack the details. traces, application traces can point to a problem, but they aren't specific enough. And then the UI tools typically lack integration to be able to correlate all of those together. And then, the logs are rich in detail, but with high volumes, it's very difficult to search if you don't know a custom query language. And so those are kind of the things that Datadog starts to solve today. So what is Datadog? Datadog is a observability platform, and we usually talk about the pillars of observability: metrics, traces, and logs, and being able to correlate those all from a single pane of glass. So Datadog is able to take all of the sources of data, whether they're on premise, in the cloud, in multi-cloud, or even private cloud environments, and we bring that into our SaaS platform. Once we get it into Datadog, then you're going to be able to start adding intelligence to that data. So start doing predictive analysis, try and prevent the issues before they become customer impacting. And one of the unique things about Datadog is that it is a single agent architecture. Why I mention that is important is because it really helps with the ease deployment and management of the platform. So that same agent that does the infrastructure monitoring also does the application performance monitoring, the log management, and everything you see here that's really part of observability holistically. Real user monitoring, synthetics, service level objectives, which was what Ryan will talk about later this evening. And when we bring that into Datadog, then it all becomes part of that same single pane of glass, so that you can now improve collaboration across teams, whether they're in dev teams, IT operations, or in security, so that you can really start to reduce your mean time to detection and mean time to repair, so that you can avoid problems altogether, and or start to get software cycles out faster by creating almost observability as code with some of our partners. And so the kind of customers that will typically come to Datadog usually fit a very specific environment. They have a variety of disparate monitoring tools. They'll have one for infrastructure, one for APM, one for logs. And so then it becomes a finger pointing exercise to say, hey, no, the infrastructure, my monitoring solution says it's fine. It must be the code. So then they send it over to the development team and they say, no, it's fine with us too. Well, that's really where you start to get into the challenges and really have a lot of manual correlation, where we want to try and automate that very much. More and more customers are getting into more modern technologies, Kubernetes, containers, and environments. And really, the problem that arises for a lot of the customers prior to moving to Datadog is that it's slow to adopt. They can't get their release cycles of their software out faster, and or they're starting to lose revenue because outages are occurring longer than they should, thereby impacting revenue for the organization. So what they're trying to move forward to is that single platform for observability. This allows you to reduce your total spend of observability tools. It also now able to have people work from that single source of truth and collaborate much faster. And you're going to see that in a demonstration, how that is actually done. And so this kind of leads us to, like, an example is a Fortune 500 coffee chain. Everyone probably has been there, if not once a week, several times a week. They selected Datadog really because they started to shift workloads to the cloud, and they needed a solution that would scale and reduce complexity in their environment. So everything from the infrastructure monitoring, APM, log management, all in one UI, and the results have been fantastic. We're monitoring one of their most important applications. That's the card that you utilize every time you want to go swipe and purchase coffee. And so we're delighted to have them as a customer. Also across Western Canada, for example, we'll have many other, not just Western Canada, but Canada organizations. And here's just a global partial list of our customers. At the top, you'll see that we're really cloud agnostic. So whether you're in GCP, Amazon, or Azure, or your own private cloud, we're able to monitor all of those and give you this bird's eye view of your entire infrastructure, so that you can not, again, have those silos of those native tools. And virtually every industry that we're working in, whether it's financial services, energy, gaming, entertainment, and more. And so with that, this is the t-shirt that that'll be helping give away here at the end. I'll ask some questions at the end after Ryan's presentation. And again, it's going to come down to who can type the fastest. The questions are going to be very basic. So hopefully we'll have a little bit of fun with that. Any questions from anyone about Datadog here? If you do have some, please, what we can do is use the chat feature, and we will turn it over to Ryan for the technical overview and demonstration. Thank you.
All right, thanks very much, Brian. And thanks for the intro, Allison. So what we're going to talk about is a quick sample app, and we'll go on from here. But basically, imagine that you've got something like Uber for dogs. We called it Datadog because we've got, I guess, no sense of humor, maybe dad jokes rules here. But basically, the premise for our app is sometimes you aren't in a situation where you can have your own dog, but you really want to play with one, or maybe you've got a dog and you want to have another dog over for a play date, that kind of thing. So Uber for dogs. Imagine if you could order a dog, a puppy or what have you, to come over and have a play date and then go away. That'd be awesome. So this app could be for you, this fictional app, I should say. And this business case is like obviously totally novel and unique. All right. So imagine you could like swipe right to set up a play date, or swipe left if you're a monster, if you actually don't like the dog. Basically, it's like a social network for dogs, essentially. So this is a quick like mock-up, obviously, of what the app might look like on a pretty dated looking phone at this point in time. So we're just getting going in our app, and we're pre-monetization, but we've got some runway to work with. So we've got some ideas and things that we want to expand into, got some features and stuff in the backlog we want to get to. We've got the app running and some infrastructure in place. Let's say it's in the cloud, but we don't really know how well things are working. So we know we've got users, we know that they're using the app, but we don't know maybe like how long they spend in the app, how often they open the app per day, or maybe if they have a problem on their side, maybe we don't even see it on our end because it's crashing, it's not hitting our servers. So we have no idea what's happening. It takes a while to troubleshoot anything to figure out what is broken, and when things go wrong, maybe we're outputting like trace codes that users can give us, and we can go manually look those up in the logs, or perhaps they can like recreate the steps or tell us the steps and we can recreate them, that kind of thing. So that's where we are. You've probably all been here before. You launch something, it's working, but you don't know how well it's working. So welcome aboard. I think we've got some attendees here. So you're all welcome to join us. And again, we mentioned in the chat, if you've got anything in the chat that you want to like talk about or want to see in the demo, let me know. But imagine that we're all on board. So we're all within this company now. Just gonna see if I can bring up the chat here. But imagine that, so we're all in this company, the Datadog company, and we're trying to figure out, so it's launched. You're on my team, so we're all together. And one way that you can help me hit the ground running is to help us with the observability of our app. So when it's running, how do we know what's running? Is it like black box monitoring? Is it white box monitoring? Can we see the internals? Are there some things that maybe involve external APIs we want to know about? We just really don't have a lot of insight into how it's going at any one point in time. So the first facet of observability that we'll talk about is metrics. So you're probably used to these and things like imagine CPU or memory, or maybe disk utilization, that kind of metric. So it could be something as like, how fast did the page take to load, might be a pretty advanced metric, or time to contentful paint. So how long the browser took to paint the app if we're using like an encapsulated browser app, that kind of thing. So there's a few metrics that you've probably seen before, things like those kind of speed metrics, right, for a mobile app, that might be something that we care about. So they're probably the first type of data that you should consider when you're beginning to gain insight into the status of your service. So like how busy was it at the time where all this is happening? Now, to make sure we're all on the same page, a metric is a data type that consists of a name, often part of a cascading namespace. So like a value, a timestamp, sometimes tags as well, that can be very handy. We'll talk a little bit about tagging when we get into the demo. But basically, tags are optional. They're just helpful in sorting and visualizing like a data layer on top of your journey. So you can make your own custom tags. Agents will typically give you some defaults to start with. So if you're in VMware, for example, it might tell you which like DC you're on. If you're in like Azure Cloud, AWS or GCP, it might tell you what region you're in. Optionally, like if you've got custom added environment tags, for example, like am I in the dev environment, it's staging environment or prod, that can be pretty important when you're going to do a deploy. Hands up if you've done a deploy in prod when you thought you were deploying to dev. I've certainly done that. I see a couple of people I worked with before, so I know you know that I've done that as well. All right, and then having historical data and relating it to other metrics allows you to spot trends and patterns. So metrics are less useful in isolation. So let's say like right now, my CPU is 100%, but I actually kind of want to know, well, what was it 5 minutes ago? Or around this time yesterday, what did it look like? Or if I'm maybe like a weekly seasonal, if we follow one of those kind of curves. So as like North America wakes up in different time zones, is it one of those sort of things? It's maybe more interesting for us to see histogram of the metric itself. So like over time on an x-axis, what did the CPU usage look like this time yesterday, this time last week, this time last month, or average over last year, that kind of thing. So without context, saying the CPU is running at 50% doesn't tell you much. It tells you what it's currently doing on maybe one virtual machine or possibly on one Docker container if you're talking about millicores. But if we have historical data to say that the CPU is running at 50% when it normally runs at 5, then that might tell us that something anomalous is going on. Maybe we deployed an instance that's too small, for example, or a quota that doesn't give us enough leeway for the processing that we need. And I'm using Datadog screenshots here. I know they're a little bit small. I can zoom into them later when it comes to a demo, but just imagine that you get CPU over time, that kind of thing. So this one's Docker, but basically, of course, you can and should use metrics in their context to send you alerts. So in dev, maybe I don't need to be woken up at 2 a.m., but in prod, if the CPU is 100, it's been pinned that way for about 10 minutes, maybe that's something I want to know about, or maybe that's something I want to develop a runbook for. And if I'm developing a runbook, maybe then I want to automate that kind of thing. But without that signal, it's hard to get into any of those steps. So the first step is to start collecting metrics and then start looking at those metrics over time and then deciding how you're going to act when they flag. So this is how you catch the known unknown. So the thing that you know that you don't know might catch. Like at 2 a.m. what was happening? I wasn't watching the dashboard. I was home sleeping. So tell me what happened overnight when I wake up the next morning so I know what happened. So the things that you know you should monitor, but for which you don't know what the current state is. All right, so cool. So which are the useful metrics? So like let's cut the gist. What do I need to monitor and how should I monitor it? There are a bunch of different frameworks for discussing useful metrics. We talked a little bit about the use metrics, so things like resources, that kind of stuff. But I'm going to talk about the 4 golden signals. You've probably heard this before, but in case you haven't, let's talk about the LETS acronym. Oh, and I knew this would happen. Sorry, I was doing some of these slides in Japanese and moving them over to English, but at the top there it says 4 golden signals, so LETS. And underneath there, we've got 4 of them. So we've got latency, so basically the time taken to action a request. So if I make a call to an API using my mobile Datadog app, how long does it take for that API to respond back? So if I call the website or the load balancer or the API gateway or the CDN, maybe, how long does it take to get back to me? The next would be something like errors. So like rates of failing requests. So imagine if your website is serving like 2XX errors, so like 200, 201, those kind of things. Sorry, not errors, but request response. It might be interesting to know what the percentage of 400 or 500 errors, that is like 400 would be like general errors and 500s might be server errors. So if I've got 90 requests that come through as green or 200, and I've got maybe 10 that come in as 4XX and none that are 5XX, we can say that it's about 10%. So the rate of errors that we're getting per request for the time period that we're looking at is about 10 requests. So that's kind of what we're looking at, 10%. And the next would be something like traffic. So the measure of demand on the server. So if we're a big hit, so the servers are getting hit quite a bit using the Datadog, it's a smashing success. Lots of people want to know about it. Let's figure out just how busy they are. And this can be interesting for right sizing or quota management or deciding how many replicas we need, or maybe which regions we need to, if we're looking at something like errors, latency, and traffic together. So if timeouts are an error, we can say, oh, maybe we do need a CDN in this different region. It's a bit of a bigger hit than we expected. The last one would be saturation. So how full your service is. So we were talking about resource utilization, but let's say we've got, like for Docker, we've got 100 millicores that we can give quota to this Docker container, but we're currently at 90s. We don't have a lot of growth there. And what we could do is create more containers, say we're in Kubernetes, or if we're in VMware world, maybe more VMs to handle it behind a load balancer. Same thing in EC2, GCP, AWS. You might want to have different servers that can handle these requests so that that saturation isn't as high as you want, or possibly you could vertically scale, so bigger instances, that kind of thing. So just to set the ground rules. Again, apologies for the top slide there.
Ryan, we had a quick question
Yeah, go ahead.
from Dimitri. It says, for the input sources,
missed it.
logs, traces, and metrics, do you use any proprietary components, or do you support integration with third parties and open source projects?
Dimitri, you read my mind. So we'll cover it a little bit in the demo section, but basically the answer is yes. So on one end, so statsd is mostly what we use, and we use something called dog statsd, which is a fork of the statsd project. So it's a little bit proprietary. It's open source, but in terms of the metrics, the counters, the gauges that we use, they're like an extension of it. That being said, it's on GitHub. You can certainly look at it. And when we're talking about integration with third-party projects and other things, so one of the things I'd like to talk about is like open telemetry or open census, or basically open agents. So we donated our agent for APM to that project. So by all means, like it is open source if you want to do the open telemetry path. So if you decided that you want to hit multiple sources, you can certainly do that. The other thing I'd like to mention, and I'll see if I can pop it in the chat here, as well as we acquired a company called Timber, and Timber has a project called Vector, and I'll pop this into the chat as well. But if you're currently running something else, let's say you're sending to one location and you also want to send to Datadog, Vector will kind of allow you to do that. So to send to us as well as to other places, it's, I believe, entirely in Rust. The configs are in Toml as well. So Dimitri, if you want to go down the path of like open source agent only, you certainly could, but the Datadog agent itself is open source. Open telemetry collector that we donated is open source as well. And they've kind of gone, like it's the project's exploded. I think it's quite popular on GitHub. So certainly you can do that. And thirdly, if you want to collect and report to multiple locations, or possibly just have your offline metrics as well as Datadog, you can do that too. So yes, and we're certainly proponents for open source, and we can understand the need or the want to be able to, one, be involved, but also look at the source itself. You have to do like an outage or something like that. So yes, we certainly do. All right, so the first thing we're going to do with our Datadog app, so we can see that error rates are up in our app, but we don't really know what's happening. So what's going on? And you've probably seen this as well. So you do like a launch and things they're going along swimmingly, everybody's happy. And what will happen is you start to see errors creep into your service. And these can be unforeseen circumstances. I've seen them things like CDN cache timeout, like I forgot to expire my resources, that kind of thing. Or maybe I'm doing database replication across region and it's not replicating as quickly as I thought, that kind of stuff. So they're going to load a page and getting a 400, the page is there, but it's not there yet, that kind of thing. That can certainly happen. But a lot of times what you'll see is in the logs or in your metrics, or maybe users are reporting that they're getting errors and you're trying to figure out, well, I'm replaying this and I don't see it. So how do I find out maybe before they do? So this would be like a job for logs. Personally, this is probably where I'd start, spelunking through the logs. So I want to start looking through and figuring out if there's any trends that I can find. Generally, I would do this manually. So I'd log on to a server and run a tail and see what I can do. Oh, I see that there's another one in here from Nikhil. Okay, so Nikhil, I will get to your question a little bit later. It looks like it's about like log collection in Azure. So there's a couple of different ways we can do that as well. But basically, in the logs, as we're talking about, we can use like a default collector that they're using and maybe scrape the logs and send them off to Datadog. We can also do platform collectors. So say if you're in AWS or Azure, I believe GCP as well, you can actually collect the logs natively and send them off. But I'll go into that a little bit when we talk about the demo, because I've got some of that set up for you. So hopefully I can help you. So we'll talk about the subscriptions, et cetera, the Azure, very specific Azure stuff when we get to that. But basically, along with metrics, I consider it to be two elemental facets that comprise of more advanced monitoring features. So you've got your CPU, your memory, the space, that kind of thing. You've also got logs that your devs are writing for your services, maybe for your web server if you're using something like Tomcat or IIS or Nginx, what have you, maybe Jetty if you're trying to go very fast on the Java side. Those will emit logs as well as they receive requests. On top of which, when we're talking about like the Azure, like Nikhil's question, Azure and AWS and GCP will also have platform logs that you can look through. Not to belabor the point, but there's a lot of logs, right? So sometimes it can be a little bit complicated to figure out where to start with the log. So whenever something happens, or hopefully whenever something happens, a log should be generated. Ideally, your logs are not only readable and easy to parse, but also contain lots of detailed information. So I see some people I've worked with before, again, in here, and like you can fight the good fight about JSON or maybe text-based logs, or at least delimited in the same way logs. Or you could start sending all the logs to a service. It doesn't really matter which, and then start writing up rules to handle the logs. It's sort of up to you. But the idea is as they come in that you're able to get that signal to noise ratio higher than, say, me logging onto a server and running tail on each server at a time. And I don't know how many monitors I'd need if I've got, 5 servers, 50 servers, 500, 5,000. It becomes quite complex to start aggregating logs over all those. But we're talking pretty simple. Let's imagine we've got one server on the cloud that's running Datadog. So it's even better, as I mentioned, if you get a structured format. So an object format is great in JSON because it makes it easier to parse and analyze them. But logs are particularly useful when you need to investigate a problem that you haven't been monitoring, where a single data point isn't helpful. So one log line is not going to help you here. Show me the trend. Show me what's actually happening. And as a bonus, your aggregated logs now will help show patterns of log events. So if you do errors over time, for example, we're seeing more errors this week than we saw last week, or more errors this Black Friday than last Black Friday. Those kind of things might be important to you to say like, hey, what changed recently? Like what deployment did we recently have? Let's go look at our commits in Azure DevOps or GitHub or what have you. Let's figure out what code landed prior to this happening. If we see a spike in errors, what happened just before that spike, that kind of thing. So you can filter these logs to gain new insights and identify different causes, maybe new problems. It's pretty exciting. Now, especially coming from the systems and ops engineering world, there's nothing I loathe more than hearing someone complain that it's just slow. So it's hard to describe like what slow means, or maybe slow means different things to different people. So I think the last time I read the Mika report, she was saying that 3 seconds feels slow now. So if you go to load a web page and it loads in over 3 seconds, that might feel slow to you. When I first started out, because I'm ancient, of course, I started pre-internet, 10 seconds was good. And then we get down to 5, and then we get down to 3. And I think on mobile now, if you're loading an app and it doesn't load within a second, you notice. You're not gonna say it's slow, but you could say, hey, it's slower than usual. Normally when I go to load Gmail or when I go to load Outlook or something like that, it's faster than this. It doesn't feel right. It feels a little bit off, that kind of thing. So people are attuned to what normal behavior means, and they'll report that things are slow, but it's often difficult if you don't have like a gauge or a metric around what slow really means. Sorry, I'll speed up a little bit. I could talk about this stuff all day, but basically this kind of problem is frustrating and it's unsatisfying for everyone involved. So the customer will want to make it better by reporting it to you, but also unless the system was at capacity in one respect or another, it can be difficult to get detailed information about the apps. So we need better info. So one thing that's super helpful is traces. And again, these are facets, but they're kind of like, we were talking about pillars of observability. The reason we name this facets is because you'll see there's more ways of looking at this. It'll be security and deployment tracing and RUM and synthetics. There's quite a lot out there to cover in terms of signal, but we'll go over the 3 that we talked about that Brian introduced, because I think they are important. So traces are a more complicated type that can be thought of as a bundle, timing metrics, a bundle of timing metrics all associated together. So imagine like this thing happened, then this thing happened, this thing happened. So I'll give an example. So I load the Datadog app, and the first thing I load is the logo, and the logo comes from a CDN. And then once it loads the logo, it might load the text, which comes from possibly a local cache on your phone, possibly a database call if we're doing updated CMS stuff. And then there'll be some queries that hit an actual database and say like, who am I? What's my user ID? When's the last time I might have logged in? Updating counters, that kind of stuff. Let me know, like I've got new connections available. So there's actually quite a bit involved in that session. It's almost like a cascading, like waterfall. So they load at the page, then they load the logo, then they load the content, and they load this. You can see it kind of drill down. But if it's loading sequentially, some of these things can take longer than others and delay the rest of the page from loading, or you could load it like lazy loader or what have you. But there's a lot of different ways of actually looking at that proper session and figuring out everything involved. Maybe it's a font, like a web font that you've got hosted on a CDN. So there are many ways of accomplishing this, but it's most commonly done with a request ID or trace ID that's passed along different request payloads. And if you read the papers on this, people will call it baggage. So as your request goes through it, it picks up bags. And as it's picking up those bags, the request will transport them from service to service, and more things will get added to the bag. So when I hit the database, it added in some request latency, that kind of stuff. There's a lot going on. Now, it's a lot more complicated than this. I'm keeping it simple on purpose, but basically, as you go along, imagine traces gathering information, gathering tags about the service, that kind of thing. So getting started with tracing usually begins with like an include or import statement, depending on your language of choice. From there, you'll begin receiving traces. And depending on that language and framework, that should be enough to get started. So if we've got any .NET users in the crowd or on Java, those are kind of the languages where, because you can inject it at runtime because it's compiled, you can actually get a lot of information about the actual code. So I'm looking at it over here, but basically this is the kind of that flame graph that I was talking about. So this span basically says that we called a Ruby backend service, so rack request, and then Ruby actually called Mongo, and we can see which took the longest in here. So rack request called Mongo, then went back to rack request, which then called Rails action. Again, these are pretty small. I'll zoom in a little bit when it comes to demo time, but you can see actually as these get bigger and bigger, you can start seeing what took longer and longer. Now, if the flame graph view isn't to your liking, a span list view is available if you find it to your preference. So this might be, let's say you're using something like a web framework that involves many different components as well as microservices, for example. This is where the spans become very important. Let's say you've got 5 microservices. It's not too hard to figure out what's going on, like an auth, a front end, a back end, maybe a user microservice. But once it gets a little bit bigger, you start adding things like calendar services, scheduling services. With Datadog, you might have things like maps so that match with people locally. It becomes more and more complicated as these calls start to call each other. And it can quickly spiral out of control. So once you've got some services instrumented with the agent and APM, you're going to start getting an interactive service map. So you've probably seen something like this before. So imagine you've got bubbles that introduce your services, and the colors of the bubbles will let you know how busy they are. They could be something like octagons or squares, what have you. The shape doesn't necessarily matter, but the relationship between them does. So in this case, you can see that our web store calls our test service as well as Mongo. And it's at a glance, you can tell what's going on here. So we've got one service that calls 2 others, and 2 of them are actually having errors right now. So we can click into each of those and figure out what's going on with them. Now, what we like to call complexity. So this looks like a bit of a mess. So this is a lot of services going on, but you can sort and filter on the service names, environments, data center, and really anything else that you've got tagged. So in this case, you can see that they're sort of clumped together, and these are probably different shards, so maybe regional shards, or A to N and O to Z shards, that kind of thing. So they're split up a little bit. They could be something like dev, though dev shouldn't necessarily be talking to prod and staging, that kind of thing. You can start filtering through them. Maybe these are cloud-based, so I'll get something on GCP, something on AWS, I can start sorting through them. But once you zoom in, like when you pick one of them, you can see that there's actually quite a bit going on here. So a lot of this is AWS stuff. So it's us calling multiple things within AWS, but you can pan and zoom quickly to get the interaction that you care about at the moment and start singling them out. So looking for maybe the ones that are red or maybe the greens. So maybe you got some tests like synthetic. So you've got some synthetic traffic that hits the website that makes sure that your site looks somewhat like what you intend, and responds in a given period of time. So that's going to work fine on your machine or in your CI, but how do things look like for people outside of your immediate region? So let's say we're serving people in Western Canada, but maybe what does Eastern US look like, or South America, or Europe, or Asia? What does it look like for that experience or that client who's trying to run Datadog on their end to get it firing going? Welcome to the next facet of observability. Sorry, that came out wrong. Observability. So this is synthetics testing. So imagine when we talk about that synthetic test. So instead of allowing or having your users tell you, hey, there's something wrong, imagine that you could go through and have a virtual user who would hit your site and go through an interaction and set up a test for you. And imagine that along every step of that path, we could actually hit the site, let's say like load Datadog, load the most interesting match, and then do something like try to test a match. Imagine if we could take a screenshot, and again, this is a little bit small, but imagine that with every one of those mouse clicks, we could take a screenshot and figure out how long it takes. Now, this will of course depend on the region that you're going in. So if you're in Azure, maybe you want an Azure tester that's like closer to the Azure network, or maybe actually you want something testing from AWS to Azure, or maybe from GCP to AWS, depending on what you're trying to test, or like from one region to another to see if it really does make sense to launch in Europe, or maybe we can get by serving that from East US for now, that kind of thing. So without going through the trouble of standing up more instances just to run these virtual synthetic traffic across the world from which you run a test, we can essentially help you with that. Now, combining the ideas of synthetics and APM, but from the user's perspective, we get what's called real user monitoring, or RUM. You've probably seen tools like this before. So when you load a web page, imagine that there's a piece of script that actually loads along with that page, or maybe you're running like a mobile app, and when the app loads, it will load something with the app that will let you know, and let you, like us on the team, know how that experience looked like to the user when they load the app. Now, let's say the app crashed. normally you get nothing, but a lot of times what you might actually be able to do is quickly send off like a signal just before it crashes, so you actually get something from it, or like crash analytics to let you know what's happening. And it can be really valuable to figure out why things like that happen. So you can use this to help diagnose a wide variety of issues your customers are experiencing. It shows from the user's perspective where time is spent, and as they wait for a response to request, what's actually happening. So is it like maybe I'm in the elevator and it's like a networking issue, or maybe I'm like in a mesh network on Wi-Fi and I'm jumping between access points, something like that. Or maybe I'm going from Wi-Fi to cell network, or vice versa. So I was taking a walk at lunch while looking at a website, trying to find a match for my dog. I come back into the office, but I swap networks. What does that look like? Does the session stay alive? Does it not? How can we tell? All right, so we've talked about a lot. So we talked about metrics, we talked about logs, we talked about APM, synthetics, we talked about RUM. So these are a few different facets. There's a lot going on. But one thing you'll probably want to do is take all the data that you're collecting and highlight all the things that you want, that we care about most for Datadog. So not specific to, let's say like a cloud vendor or a technology, but maybe taking piecemeal from those pieces that we can monitor natively and putting them all together so we can see them in like a custom built dashboard. Now, I'm not saying you need to have a dashboard on the wall that you watch all day long, but maybe in an incident, it gives you a way to quickly go and assess the situation based on the breadcrumbs that you left yourself before. So whether you're starting from a built-in dashboard or starting from scratch, or a notebook that turned out to be super helpful in diagnosing a problem, creating useful and informative dashboards can be seen as a bit of an art. So a fair warning, sharing amongst your peers and teams can turn competitive so you can produce the best dashboard. I've certainly been in this kind of competition, trying to figure out like who can relay the information in the best way to a VP during the time of crisis. It's pretty important. So I've been burned by like logarithmic Y scale, for example. Often that will require explaining, but it can be interesting to maybe display things in a different way. So let's show the normal graph and then the one with logs to the left of it, the right of it, so we can compare and see the smaller things, that kind of stuff. And as much as we love dashboards, you probably have more important things to do than stare at them, as I mentioned. You probably don't want to just put this on the wall and look at it from time to time and look for problems. So you shouldn't be expected to watch dashboards 24/7. So what we can do is point machine learning to the dashboards and let them take care of you. So what we would normally talk about in this case is like alerting. So instead of saying, hey, the rate is high, I should manually press a button and send an alert. Maybe what we can do is say when it crosses a threshold or a percentage or a rolling average, or if it looks like an outlier, or maybe it's unseasonal. So let's say we've got seasonal sales of Datadog. It's more popular in the summer, for example, than it is in the winter, but we see that there's actually a spike in the winter. Why would that be? Maybe we should send an alert. Not something that wakes somebody up at 3 a.m., but maybe an informal informational alert, letting you know like, hey, by the way, did you know we're really popular right now when we're not? Why is that? Maybe we should look into it. So alerts are a facet that's pretty straightforward. So when a threshold is broken or a service isn't available, let me know, let us know. Let us know in these ways and maybe give us some context. Let me know what you think is going on. So is it something like clock skew? Maybe the app on the phone is off by over 4 minutes, and because of that, other things are happening. Maybe it's something like the CPU usage is high, as we mentioned before. Maybe it's something like we're actually sending too many logs during a certain period, which seems a little bit weird, that kind of thing. Now, this is a bit old school. I apologize for those who haven't seen one of these before, but like alerting is often conflated with paging. So they are similar, but not necessarily the same. So you should be alerting on many things, but be very judicious about when you actually intend to interrupt someone. So I keep mentioning like 2 or 3 a.m. because I was on call for almost 20 years. And I certainly was woken up a lot of times overnight. Sometimes it was myself, like I would set up an alert that didn't need to be there. And I'd wake up and realize, oh, hey, by the way, this like past me, this wasn't what you wanted to do, and then like fix it. Sometimes I would do that to other people who were on call, and sometimes they would do that to me. It's all fair game, right? You set up things that you want to do to alert people next time it happens, but maybe you could have set up a immediate action or set up like a document or something like that. Maybe the alert could have a link to like a Confluence page or a SharePoint page or a Google Doc, that kind of thing. But alerting versus paging is a huge topic on its own. One of our founders, Alexi, wrote basically just some background basically about how to alert and page. I'll share a link in the chat here in a bit. But basically, the next thing we get into, and sorry, this feels a little bit exhausting, but we're almost done. got about 10 slides left here, but basically SLOs are kind of the next thing that we get to. So SLO stands for service level objective. You've probably talked about SLAs before. So service level agreement. So that would be like your business telling you, hey, we can only afford to be down 4 hours in a year, or 4 days in a year, or maybe it's 4 weeks, depending on the service. So generally, as you're pushing out a service, you'll come to kind of an agreement of what you deem acceptable. And SLI would be something like when we were talking about metrics, or like how slow a page works compared to what we assume should work, like how often we miss our SLIs. So it'll inform our SLOs. So the SLA and the SLIs will go together to allow you to define a clear target around application performance. And then those will ultimately help teams provide a consistent customer experience. So balancing feature development with platform stability and improving communication with the internal and external users is kind of the goal here. Your users are probably fine with less availability than you expect, which is like, that's all right. So basically you can set up something that's highly available, but they probably expect you to have an outage as long as you're clear about like what happened. I definitely don't take things down on purpose, but always be transparent if you can about what happened. So most of them won't know what like 5 nines means, and if it doesn't work, they'll probably reload your page, which might be okay. Some of them will be very vocal, and that's great as well. And that's kind of why you have those virtual users, that synthetics monitoring to tell you. And this is going to be a discussion that will happen with your company stakeholders. So again, similar to the SLAs and the SLIs, deciding how you figure out what to measure in order to come up with these. So one of the canonical references in terms of SLOs themselves would be the Site Reliability Engineering book. Now, this is free on Google's site, I believe, still. So if you're okay just reading a web page, it's there. It's an invaluable resource. It came out a little while ago. I think it's 2016 is when it came out. So there have been a couple other books that came past it. If you prefer something that's a little bit less pedantic, maybe, and a little bit less like research, maybe the workbook that came out after this might be more interesting to you. So it's like practical examples, but they sort of go hand in hand. These two books I think are great. There are other resources out there, but this is a good primer on how to think about the availability that you're promising to your clients and ways that you can engineer your architecture, your services, with the way that you're deploying things in order to handle the facets that we're talking about. And in addition to documenting the availability promise that you make, you can publish your status, and these kind of widgets let you know what kinds of work you should be prioritizing. So imagine that like this status page is public to people, so they can actually go on and see, hey, what's actually happening with Datadog? Like, how many people are on there right now? Maybe that's not what you want to say, but maybe it is. How many matches have happened today? Sometimes these roll-up metrics are very important for people to see, or like, what's the current status of the app? Having a public status page is very important. So things like new features or improving reliability, trying to decide which to prioritize can be very handy, even if you're just sharing like one of these dashboards out internally. So like I've developed services, and we had a little metric like, how many days since downtime have we had, for example? And depending on what you're launching, it could be pretty bad. You could start from there. I'd say that's pretty bare bones. So if you've not had a failure for a couple months, maybe that's not the metrics you want. Maybe you want to know how slow it was, or how often you're hitting that 1 second page load, which is your target. You want things to quote unquote feel fast. So you want to load within 1 second. Maybe that's your indicator, and it's part of your SLO. So it's a huge topic by itself. So understand there's some resources to help you learn more. So Datadog's running pretty swimmingly. People are pretty happy with the performance, but one of our coworkers says like, hey, you can tell we're successful because we're getting attacked. So people are actually hitting our platform and trying to guess, maybe they're guessing URLs. Like I see that one a lot. People try to hit WordPress URLs on a new service that you've identified. So you're running a mobile app with an API backend. You thought they wouldn't be able to guess the backend. Guess what? They found it. They started adding slashes to it, doing things like injecting Unicode into your URLs to see how your web server will react. It's pretty common. It will happen. And as soon as you hit like past a certain number of users, there'll be people out there that just sort of, they're kind of knocking on the door to figure out what's going on. So even if you have dedicated security teams, there's going to be information that you're already collecting, but it's getting buried under all the other information that you're collecting. So imagine when we were looking at logs, imagine those are streaming past for thousands of servers, and one of those in there is one person trying to guess URLs. And maybe they look like page load failures, but actually what they're doing is like exploration. So just information gathering. It's not that serious at this point in time, but maybe you want to mark that IP as not necessarily something you need to block, but possibly suspicious. Maybe it's a bad actor's IP. maybe it's somebody else who's hit the wrong site. Maybe you're reusing, this has happened to me before, like reusing a cloud IP for somebody else that used to be there, and they're hitting the wrong URLs over and over again because the IP has been reused, that kind of thing. So it's not necessarily malicious, but it is an indicator. And oftentimes these indicators will be buried in your logs, and you want to surface them. So like, which one of these logs is unique? Which one of these signals is a security signal versus just a signal, that kind of thing. So it can be a real challenge to surface that kind of information and then make sense of it. It can be quite tough. So is utilization served like new user interest, or is something more nefarious? Are we getting hit by a DDoS? Is it something like, we've got some examples in here, like AWS config modified, like somebody got into my CloudTrail and modified my config. Now that's pretty advanced. Maybe that's what they're doing. Maybe it's somebody who's on call who's actually trying to fix something, and they logged in with like the wrong user account kind of thing. You can see Christopher Jones was in there doing it, and maybe it was after hours, and it's not like a security thing, but maybe we should let Chris know, like, hey, let's just work 9 to 5, Chris. There's no need of doing this, or maybe let me know before you change CloudTrail config, or let's put in a change request or a PR or what have you. So again, maybe not nefarious, maybe it's something that's normal day to day, but maybe there's a process, a procedure, some guidelines, some guardrails that we could set to help Chris next time this happens. And then maybe there's something that's actually serious. So further down here, you can see the account takeover, so the ATO. So someone actually tried to take over our account using a brute force password guessing. So they've got a list of passwords that they downloaded from who knows where, and they're just running it at our website from their IP. Not the smartest way to attack something, and definitely something that you'd see, but if you're not looking for this kind of thing, you might not notice it. Again, if your site's really busy, if a lot of people are matching the dogs, you might not notice that someone's actually trying to brute force the password. And the other thing that can happen is they won't do them all at once. They might do them slowly. So if you're not looking at like 6,000 attempts at once, but actually what you're looking at is 600 attempts per day over a period of 3 months, it's a totally different story. And you might not surface that if you're just looking at log line by line, that kind of thing. So having a way to expose just your security related events can be key to making sure that you're not the next tech news story. We don't want Datadog, like Datadog, on CNBC talking about a big hack where everyone lost the dog's dog tag IDs or anything like that. That's not what we want. All right, so we covered a lot. My apologies. I've tried to talk slow, but if I talk too fast, by all means, hop in the chat, let me know. I know we've got some questions here about Azure that I'll cover in a bit. We talked a little bit about the agent collection, so I'll try to cover both of those. But basically what we covered today is like, there's different facets of observability. And you can tell here that I'm being careful not to say pillars, just because like what happens when you're over 3 pillars or 4 pillars or 5 pillars? Are we building like a big Greek edifice? So what we actually care about? We pick the word facet just because it feels like maybe different lenses that we can look through. So imagine you've got different pairs of sunglasses. You get rose-colored glasses when you first launch. Maybe the blue ones or the yellow ones are your security-focused ones. Maybe you're wearing multiple pairs of glasses or different hats, depending on what role you're doing in the org. You've got a hat on a hat on a hat kind of thing. But there's a lot of different ways of observing your environment, be it like black box metrics to let you know what the output is of your service, as well as white box metrics to let you know what's inside of the service. We talked about the let signals, there's also the use signals. So to figure out how saturated, what's actually happening. We talked about looking at it from the client standpoint. So the client as in like a phone client standpoint, as well as the user standpoint. So what they saw on their phone, as well as once you hit something like your API gateway, and maybe after that, your load balancer, those logs that are generated from those sources within your cloud or within your on-prem infrastructure. Let's say you're running like a Citrix NetScaler, for example, blast from the past. It's still kicking around, and you've got it actually being servicing traffic that's internal, and you're trying to figure out what happens when someone calls in from another office over the VPN and they hit internal services. This can help you suss that out. So the other is the elemental observability data type. So what is like our foundation here? So we talked a little bit about metrics, logs, and traces. In my demo, I'll go over kind of pivoting between those, but basically setting yourself a foundation. Now, again, this is about Datadog, but if you're using something else, I feel like a lot of this will be table stakes. So you'll know to be able to go between those different views in order to figure out what's going on. And in some cases, it might be that you're looking at your logs and you realize, hey, this is a great log, but what I really need is a metric. Maybe we can start instrumenting our code, and that's when we start adding in the traces and the metrics. Right, and the last one here is combining those Ollie methods. So this is Ollie, O11Y if you've not seen it before. So observability, instead of writing it all out, sometimes we'll do that. Elements and filters to solve different problems. So being able to slice and dice and drill into it kind of thing. All right, so I've got one question that came in, and then we'll do demo time. So where do you store the data and how do you achieve scalability? Dimitri, I have to ask, so it depends is the easier answer here, but do you mean Datadog or do you mean for yourself, I guess would be the question. So just let me know there and then we can kind of go through it. So, Datadog, right. So we are multi-cloud. So we're deployed on the clouds that you know and love. And if you're in Azure, for example, we can offer you an Azure cloud. If you're in Google, we can offer you that cloud as well. Same thing for AWS. In terms of the storage itself, though, it is not on-prem. I mean, if that's what you're getting at, you can certainly monitor on-prem stuff, but in terms of the storage itself, it's in Datadog. Now, if you need to mask data before it gets in, which is a common request, of course, we can help you do that. I mentioned Vector a little bit before. I like Vector in that it's got very powerful masking abilities, so you can set up things to be like wide, like a big surface area basically to mask, but also our clients itself will do it. And when I mentioned open observability, just to dovetail into the answer I gave you before, we can certainly do that as well. Which is, I think, maybe the next kind of question you're getting at is like, okay, it's there, and then what? Like, where is my data? How do I get it out? Okay. All right, so if I can swap tabs here, there we go. We can talk a little bit about, so this is live, like I can click around it here, but this is basically the logs view. So we were talking about logs over time. You've probably seen something like this in a lot of the different tools. This isn't like, it's not amazing, all singing, all dancing in terms of this view, but like one of the things we can talk about is sort of that pivot. So what does it look like when I got a log line that comes in? So it looks like this one here. Hopefully the font is big enough. If not, let me know. I'll see if we can zoom in a little bit here. That might be a little bit better. Hopefully that's okay. Let me know in the chat if the font's too small and we can kind of talk about what this looks like. So imagine you're live tailing a service and things are flowing past and you notice one that comes in that's a little bit interesting. So someone gave you a session ID, you've got that session ID here. So it's like ETGBBJHNES. Someone reported that this session in particular is ongoing and they're having problems. Let's figure out what's going on. You can kind of see on the graph that most of our traffic is that in terms of that ratio is actually good traffic. It's not a lot of errors. So we can kind of click in here and look at it. And I realize we're running on a little low on time here. So I'll go through it, but if you've got anything you want to see in the demo, definitely let me know. So what I'm trying to demo here is that between your logs and things like metrics and traces, you can certainly pivot between them. So when I click on this log, you can see all those. Oh, sorry, I think I hear somebody there. Go ahead. Not so much. Okay, maybe somebody just unmuted by mistake there. But basically, as these are coming in, we can start getting a lot of tagged information about what's happening. So like what host it's running on, for example, what container in Kubernetes it's running on. So it gives us like the context basically of what's actually happening. And I can drill into each of these and I will in a moment, but basically just telling us, hey, this is Ruby code. It's running on this pod. It's using this Docker image, for example. Maybe this is out of date, that kind of stuff. We can actually drill down. So all this tagging here, there's 53 of them. So if I click on it, you can see there's a lot of tags. What we can do is actually pivot between those tags. If we added like different environments, we can tell what app it's in, what zone it's in, that kind of thing. And for each one, as the events come through, we've got these event attributes. And when we were talking about facets, so there's also log facets. So for example, if I decide that this level here is actually a facet, I could like add a facet to log level. This is kind of generic, so it's in there already. But if I wanted to just compare like error logs versus info logs, for example, that's built in. But if I decided that like this OID is something that's actually a facet, like I want to track all these OIDs, or maybe this user, or maybe I decide that, hey, this is something that should be masked, I can start doing that from here. But as the event attributes come through, if we've got them linked to traces, basically we can take those trace IDs and start drilling into the actual trace. So we can see, again, very similar to what we saw before. So we've got rack request is actually calling into ASP.NET Core, and the ASP.NET Core is then calling an actual Postgres database. And in the Postgres database, on top of that, we can actually see that there's like a select star from session square. Like this isn't the best query. It could be a little bit better. Maybe we need pagination or something like that. But we can see that this specific query is actually in the P97 percentile. So it's in the top 3 slowest queries. So it's actually pretty bad. So we can see that it took 191 milliseconds. Not terrible, but definitely compared to the rest of our traffic, it took a lot of time. So what we probably want to do is look into the query and maybe fix it up. Again, maybe pagination, return 5 results at a time instead of 5,000, that kind of thing. Maybe that's what we got to do. And then from there, we can actually pivot right into metrics as well. And again, I'm showing you this in a logs view. It looks a little bit compressed on the right-hand bar, but for each of these, I could do like a host dashboard, the host itself, or just a container. Same thing for traces. That can actually be the trace details. And that's what I'll do. So in metrics, remember we talked about CPU, load, memory, swap, disk usage, network, that kind of stuff. So we track all of these, for example. So if you're in a networking shop where it's actually really important to follow networking, we can do that too. So I'm running a bit at a time, but basically what these look like once we're in here is like, you can actually, you can actually see like we can pull up each one into their own side, into their own page. We can start drilling through them. Same thing for your metrics. If you want to just look at this container, we can do that. In fact, if you want to actually share it to people, we could do it from here as well. We could actually like share this dashboard out for these to do. Will the recording of this? Yes. So Andre got it. Yes, it certainly will. Okay, so I got about 2 minutes left. If you get any questions, let me know. Again, hopefully that gives you kind of a big overview of Datadog itself, what we can do, as well as a quick demo, like, hey, it actually works. Like we've got some demos that we can certainly talk about. But let me know if there's any questions in the chat. And I think we've got some questions that might come through as well if you want a t-shirt. But happy to answer any questions if you've got time to stick around and talk about Azure specific stuff. I know when we were talking about like Datadog US CD site, like creating Datadog resources in Azure to link your subscription data. Oh wow. So Brian, I think you've got one link there. I will add another in that we can actually allow you to onboard right from Azure Marketplace now, which might actually be interesting to you because we can do what you're talking about automatically now. The reason I know this is because I was asked to actually talk about this a few times, but Nikhil, hopefully this helps you. There, so basically right from Azure, you can link up Datadog and start getting some of this stuff out of the box. One of the really nice benefits that I saw personally, having fought with SAML before, is like easy to use SAML integration that this does. So essentially imagine that like when you log into Azure with your credentials, you could use those same credentials to log into Datadog. That might be powerful for you. On top of which, it does make log collection a lot easier. There are a lot of logs in Azure, especially when we're talking about like API gateway, or I talked a little bit about load balancing. Things like Azure DNS or maybe even Azure Active Directory. There's a wealth of info in there that I did not realize was available. So it might be an eye opener for you, let me know. But I really actually think the marketplace is pretty interesting. So imagine that you're like in Azure and using your search bar, you just type in Datadog, one of the drop downs that it gets will actually be the marketplace. And you can click that. And if you've already got a Datadog account, it will link it for you. If you're new to Datadog, it will set one up for you and then allow you to do things like billing through Azure as far as I can tell, which is pretty nice. But I'm sure Brian knows a lot more than that than I do. Regarding the dashboards, what is the query language? Great question. So I will quickly share my screen out a bit here. So the query language, I want to say like Lucene Light, which is it's really not fair. But if I clone this dashboard here, I'll just quickly go in and kind of show you what these look like. Just move the zoom thing out of the way. So I think that was Dimitri who was asking. So if I go into, if I go into edit one of these widgets, you can kind of see the queries. So in this case, the query itself that it's getting is like, hey, let's look up a metric. So CPU system idle is a metric. So for that metric, let me then look at, like drill it down into something more specific. So in this case, we're looking at the GKE events for the default demo pool. So we've already got a metric and we're drilling into it. So in terms of that query, like it's pretty straightforward. What you can do though, is like give them labels, no problem. You can look at the raw query itself. So it looks like, again, I'm saying Lucene Light because it's kind of like Lucene Asper. If you use like Solar or maybe Elasticsearch, it's similar to that, but it's not the same. So you can see it's asking for an average, and then it's asking for an average over system CPU idle, and then the qualifier. So the thing that tells you more about it, is then it's saying for the host, and then here it's actually giving it to you. So if I go into JSON, you can actually see what the query is. So it's got like different query names. And then for each one of them, like this is a raw query, but basically it's the same, it's just marked up. In here, you can see the actual query itself. So all I did before was use sort of the HTML greater than less than to sort of show the query, but it looks like that. So basically, if you want to copy between them, you could certainly do that. Or if you want to actually look at them here, that's kind of how they're made. Now in query values themselves, so if you want to actually like write a query, you can do that too. And similarly in the logs, you'll find something very similar when you're trying to actually look over your logs. Hopefully that answered the question, but if not, let me know. Right. Are there any other questions? Sorry, that was a whirlwind tour of like what you should care about, and basically it's not all the things, but it's a lot of the things.
All right, well, thank you, Ryan. Allison, And Andre, I think we'll move to the giveaway of the t-shirts if there are no more questions.
I've got one question.
Sure.
So what about organizations? I mean, like everybody's getting to the cloud, but there is a lot of organizations that still got a on-premise legacy applications. How can you monitor both, or how well Datadog performs in such environments? You're on mute, Ryan.
I'm over here reading Andrew's comment as you're talking, so I apologize. I missed the first part of your question. So which environments is it, on-prem and cloud? Is that what I missed?
Yes.
Yeah, so the key thing there, what I've noticed personally on-prem is it has to do with tagging. So making sure like that you can separate the two. On the cloud side, you'll generally get tagging by default. So you can sort of say anything that's tagged with a region, chances are it's cloud-based. That's pretty easy. What you might want to know though on-prem, let's say you're running something like storage or VMware, or maybe some networking gear, is the on-prem info. So like when you think about tags on-prem, a lot of times, like as a former data center technician, like the things that you use, the sticky notes on the rack, or maybe the Excel spreadsheet that you use before to figure out like what goes where, those are the things that you're going to want to have as tags in order to separate them. So that's kind of generic. So to give you an example, like I would want to know that it's rack 1. I would not want to know that it's a top of rack switch. I probably want to know the manufacturer, which we'll get. I probably want to know like how many interfaces is on the machine, things that are more specific to on-prem. And that's an easy way for me to tell like which is which. So if it's DC1, rack 1, top of rack switch, Cisco, and then like how many ports it's got, then I can kind of drill down. But it's basically what's old is new. Like all the old practices that we had in the data center are still valid. Like don't throw that away. It's definitely still relevant. And when you're comparing between if you're hybridized, for example, or if you're trying to monitor two things, a lot of what I found is like those direct connect links, those VPN links, those WAN links, the things that actually connect them are maybe more important than you would have previously thought. So like the quality of service or the QoS, the quality of like packets. So if you've got like voice traffic going with your storage traffic, that kind of stuff, that's generally what I would watch to actually see the saturation of like the line, the network speed of each one. That's personally what I would do. Now this goes back to when we're talking about like older things. Generally, you probably want to do that with like SNMP monitoring, which we do support, but that's what you want to do. So again, what's old is new. It hasn't gone away. Generally, when you're dealing with on-prem to cloud or cloud to on-prem, generally you want to monitor both and tag both. The cloud stuff's probably taken care of. The on-prem stuff, you're going to have to add that manual work. Chances are you get an Excel spreadsheet or some sort of sheet somewhere that you can use as a lookup table, but grabbing the two together is key. However, the links between those sites are critical. So if you've got like a big data pool on-prem that can't be in the cloud, for example, which has happened to me in a past life, you need to know that link between on-prem to the cloud is solid. And if it's not, that you've got a backup and you need to be able to monitor.
Excellent. Thank you very much.
No worries.
I think Dinesh got a question.
Yes, I did. Can you hear me okay?
Yes.
Great. So just looking at your pricing page on Datadog, and I noticed it's basically priced per host. So how do you handle things like container workloads which come and go, as well as instances or auto-scaling instances that come and go? How is the pricing for that managed? And then I have a follow-up, which is based on serverless stuff, like on AWS, we use a lot of Lambda functions. How is the pricing for that factored into?
So Brian's a pricing expert. I'll let him handle most of that, but I believe the model is very similar. So what you call a host, it might be a container, and it might be the same price, might be less, what have you. Same thing for like Lambda invocation, it's be fairly similar. So we tried to keep it simple, but I think Brian would know the actual math between there. Whether it's one-to-one is what I don't know.
Yeah, no, it's not. So we give 100 containers per one host. So typically customers will have enough hosts that it covers all the containerized environments, but you can also purchase extra containers if it's needed, but we try and make sure that it's sized correctly so that you don't have to do that.
And I think you had a follow-up as well, Dinesh?
No, I didn't. I asked both the follow-up.
Okay, that was both?
Yeah.
Okay, awesome.
I was just trying to see how to lower my hand. There you go.
No worries. I've heard that question before, which is why I had it at the ready. I think when it comes to billing, people are always concerned about like what the primitives are, right? Is it per amount ingested? Is it per host? What have you? We try to keep it pretty simple. Yeah, Shiyun saying recommending the Terraform provider. I will recommend Shiyun. I would recommend Shiyun if you'd like to know about Terraform. He is a whiz at it, and I learned a lot from Shiyun in terms of Terraform. So if he says he recommends the Terraform provider for Datadog, I would also recommend it. He knows where it's at. His team actively uses it, and being able to define all those monitors and code has made life so much easier for us. Yeah, hard, strong yes there. So as you're moving into microservices, and maybe you're using like a cookie cutter approach, so perhaps you've got like scaffolding for each service. As you build those up, having things like table stakes or basic alerts that you've got set up for them, or maybe basic dashboards or basic like graphs that you actually want set up for your services. So for example, if you're a Java shop, or maybe you're Java and Golang, if you've got like one template for Java and one template for Golang, so that when developers go and fork that to create their own microservice, that they've got things like alerts, dashboards, and graphs already set up, it is amazing. It's a force multiplier, and it's a really easy way for you to show value as well, to be able to give developers an on-ramp to actually start this quickly and bridge that gap. Andrew Cockwell is saying something very similar. Yeah, that's good to hear. And I did notice that I forgot to share the link to the SRE book, so I'm just going to quickly pop that in the chat. It is free on the website, or if you'd like to purchase it, of course, it's available from O'Reilly, but it's totally free and well worth a read.
Okay, any other questions for Ryan or for Brian? I think, Ryan, you've been pretty quick to answer the questions in the chat anyway.
I try. Yeah, I feel like maybe it's like the Twitch streaming skills that I gained during COVID. That I'm getting pretty used to like presenting and reading chat. It's
Yeah,
I can't say I was born this way, but yeah, definitely honed this skill over the past 2 years.
Okay. Well, Brian, should we head into the quiz round?
Sure, let's do that. All right. Okay, so this is really going to be who's the fastest typer. The way that I'll get you the t-shirts, which I'll be sending them from my home address. They'll come wrapped like this, but look like what you see on the picture there. I'll provide my email here at the end so that you can send me your address for me to send to you from my address. So have your hands on the keyboards, and we've got 5 t-shirts to give away. And so if Allison, if you can kind of capture, since I can't see it, who is the first to answer the questions?
Okay.
All right, here we go. What does RUM stand for? And you can let me know once someone has an answer.
Oh, okay. Danny. No. Yes, Danny. Oh, Danny says real user metrics.
No, almost.
Jason says real user monitoring.
That's correct.
Jason.
Okay.
Yeah.
Well done, Jason. Jason Bellis.
Okay, so again, I can't see this. So if you can write down the names.
Sure.
The winner, so that was the correct. All right, on to the next one. Oh, wait, I already had that one. What are the 4 golden signals?
Danny. Well, Dimitri says let's, but Danny spells them out. Latency, errors, traffic saturation.
That is correct.
So would you accept Dimitri's let's or
Let me.
There was a lot of typing.
You want to see it in full?
Do we get like show your work effort here?
What do you...
I will say Danny was typing awfully fast and then saying she was slow, so I don't know.
I vote they both get shirts.
All right, we'll do that since I had 2 questions for lunch. All right, so Dimitri and Danny get one. All right, so we're up to 3. So we've got 2 left. And again, you can't win a t-shirt twice. So Dimitri and Danny, so you'll have to refrain on this next one. You're very fast typers. All right.
Okay.
Here we go. The next one is name 3 monitoring solutions that Datadog can do.
Okay.
Andrew got it.
Andrew says logs, RUM, and security.
He's correct. Yes, so we do have a security practice as well. So Andrew, well done. All right, the last one. And you know what, and I like Stevens as well. We'll give a t-shirt to Stephen Tate as well.
Hey, okay.
Those are what we call the 3 pillars of observability: metrics, traces, and logs. Okay, and the last one. And so if you're in British Columbia, you'll know this answer. If you're not, you won't.
Did you see the answers pile in? That was pretty fast.
Tricky question.
So Andrew already has a shirt, so it's going to go. And
We SF. I don't know what the full
I can
name is.
ship into Canada. So I just need to know where that's not San Francisco. I can ship in Canada. DWISF, are you in?
That's Dwee's name. Dwee says that's
Dwee?
his name. Or that's their name, sorry.
Dwee, are you in Canada?
Look
Yes.
at that.
Excellent. Okay.
I mean, we kind of assume, right? That was a pretty fast 30.
Yeah. Well done. Okay, so what I'll do is let me fast forward here. So this is the email. So Allison, if you can read out the people that won again, if you can send an email to brian.clendenin@gmail.com. Sorry, datadoghq.com. I'll just need, I have medium and large size t-shirts that I will send to you.
Okay, so that's Jason Bellis, Dimitri Shmulevich, Danny Wheatley, Andrew Cockrell, Stephen Tate, and Dwee. Dwee SF.
I love this dashboards that you picked, Brian. This is one of my favorite samples. It's got everything going on. This is like what Andre is talking about, right? What if I'm in VMware and in Azure? What does that look like?
Cool.
Okay, and then for everyone on the call, if you do want to do a free trial with Datadog, you can also reach out to me as well for your organization, and we can get you some extra support to help get you going. Allison, that is the end of our presentation. Thank you so much for having us be a part of the DevOps Vancouver Meetup.
Thank you, Brian, and really appreciate you coming along today, telling us a bit more about Datadog, and for the t-shirts, I'm sure they'll be very well received. And Ryan, thank you very much for your presentation and demo. We really appreciate you taking the time. And for those who don't know Ryan, he was in person at a number of our meetups when we were still in person in Vancouver. So
I can't wait. Our regular locale is just a hop, skip, and a jump away from home. So I can't wait till we're back in person again. Though obviously, thank you so much for having me. I'm humbled to be able to present to you. And I walk in the shadow of giants. I've seen quite a few great presentations at this meetup, so I'm honored to be able to present to you.
Oh, thank you, Ryan. We really appreciate it. So to wrap up tonight, we did have a question whether the presentation tonight would be recorded, and it has been recorded, and it'll be uploaded to our YouTube space in a few weeks from now. So you can look out for that. And Andre, is there anything you'd like to say to close off tonight?
Oh, just again, many thanks, Ryan and Brian, for this presentation and for the t-shirts, and yeah, thank you very much for that, and thank you, Allison, for helping to host this meetup. And again, many thanks to everyone who participated. If you have any topic that you'd like to talk about or any topic that you would like to hear, please contact us, let us know. We are always looking for speakers, or we will invite speakers if there is enough interest in particular area. So observability is definitely one of the great topics at this moment, and it's actually a very hot topic as everybody is talking about this. And I think a lot of organizations are facing similar problems. So thank you very much again for this presentation. It was really eye-opening, and there was a lot of information. So thank you, Ryan.
You're welcome. Sorry, I had to go a little bit faster at some points, but hopefully I covered this bit. And I dropped a link into some more announcements that they have recently that I couldn't shoehorn into this talk because it would have been too long. But there's a lot going on.
Perfect. Thank you. Thank you, everyone.
Thank you, everyone.
Thanks,
Good evening,
everyone. Good night.
Yep, thanks, everybody. Good night.